Example 1, add k over 2a plus bc over ax squared minus m over ax cubed. We're adding fractions. Fractions require common denominators. 2a and ax squared and ax cubed are obviously not the same, so they're not common denominators, so we need to make a common denominator. The least common denominator is created by the highest power of each different prime factor of the denominators. Highest power of each prime factor. So the only number I'm looking at is 2, which is prime, is to the first power, so that's part of the least common denominator. The next prime number, because I can't break it apart, is a. Anybody know what times what makes a?
No.
Me neither. Alright, so I can't break it apart, right? So it's prime. Even though it's not really prime, it's acting like a prime, so we can call it prime. Alright, what's the highest power of a? 1. So 2a. Alright, and then the next thing we have is x. Can anybody break down x? Something times something makes x?
No.
So it's acting like a prime number. So x. Alright, what's the highest power of x? 3. That's how you make a least common denominator. Every single prime factor to its highest power. Once you've established what the common denominator is, then you simply make it 2ax cubed. Notice I made a really big fraction bar here. In the past I made separate fraction bars. I'm going to go give you the, I think, more efficient one fraction bar technique to do this. Because the very next step after I make fraction, 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 put all the stuff on top over one thing, right? So let's just cut straight to the chase and get right to that. All right, so looking at the first fraction, it's this one, k over 2a. The numerator already is k, right? So the numerator stays what it was, but then we have to make modifications. It was 2a, now it's 2ax cubed. What's new?
X cubed.
X cubed. So I need to multiply by x cubed. The second fraction, bc over ax squared. So it's still plus bc. Okay. It was ax squared, now it's 2ax cubed. What's new? X and 2. Right? bc times 2x. So again, what it was compared to what it is, what's new? 2 is missing, 2 is new, 2 goes in. A is there, A is still there, doesn't change. X squared became x cubed. That's x times bigger, so times x. The third fraction, negative m, so negative m. Okay, on the bottom we have ax cubed, now we have 2ax cubed. What's new? 2. Okay, so that's step 2. Once you've established the common denominator, you modify each numerator appropriately over the common denominator. And the last step is to simplify the top. Let me just make one note here. Put numbers in the front of expressions. So if a lot of times numbers end up in the middle there, stick them out in front. If there's more, let's say this said 3bc and 2x, don't give me 3bc, 2x. That'd be 6bcx, all right? So multiply the numbers together. Things that can multiply together should be multiplied together. So what I'm going to end up with here is kx cubed first, plus 2bcx second, minus 2m last, all over 2ax cubed. And that is the sum of those three fractions in simplest form. A couple things to look out for that people are going to be tempted to do that you can't do. That 2 and that 2 look really tempting to cancel, right? Every object has to contain the same thing to cancel. So if this had a 2, and this had a 2, and this had a 2, and this had a 2, then go ahead. This is missing a 2, so we can't. All right? And if this is the least common denominator, you should expect them not to simplify. They usually don't reduce. I would personally stop there because I don't deduct points. If you don't reduce, I might say reduce, and then I'll put the right answer, but I don't deduct points for that. So leaving it unreduced is probably safer. Out of the probably 100 or so of these problems, 1 or 2 might reduce. So it's not that big of a deal. Get me to that point correctly, show all your work correctly, understand where things are coming from. That's what I want from you.